Hi there, in this video I'm going to talk about iterables. So iterables in Python are objects that are capable of returning their elements one at a time. So basically, if you can for loop over any object, that object is called an iterable in Python. In terms of implementation, this object would need to implement dunder iter and dunder get item or dunder get item method in order to qualify as an iterable. Common iterables in Python are list, strings, dictionary, file, sets, connections, and many more are there, and these can be subdivided into containers and generators based on how they utilize memory. Those that put all their elements in memory are called containers, and those that generate their items on the fly are called generators. Examples of containers are lists, tuples, sets, and dictionaries. Containers contain all the elements in memory, as I said earlier, at once and are iterable as many times as you want. On the other hand, iterables that generate their content on the fly are exhaustible. That means once you reach at the end of the sequence, you will have to reinitialize your object to start iterating over it once again. And these containers can be again subdivided into sequences and non-sequences. This is based on their order, or whether they can keep in order or not. So lists, tuples, and strings have their inherent order. So if you create a list, for example 1, 2, 3, whenever you iterate over that list, keeps the order. However, in the case of sets and dictionaries, that's not the case. There is a catch with dictionaries because from Python version 3.7, so did I say Python 3.7 and above, dictionaries have orders. So sequences are ordered and indexable. Non-sequences are not. So in addition to being ordered and not ordered, there's also indexable and non-indexable. As you probably have seen in your projects or Python experience, you know that lists and tuples and strings can be indexed. That is to say, if you have a list, you can do the list's name, square bracket, and then you can put the index. However, in the case of sets and dictionaries, that's not possible. For example, dictionaries are a key value pair, therefore you have to use a key to access values, so no index there. Another classification for containers is mutability. That means whether you can change the object once it's created. That's only allowed in the case of lists. The rest of them are pretty much immutable, which is tuples are immutable, strings are immutable. Dictionary you can basically change. Another criteria of classification is hashability. If a sequence is hashable, you can use it as a key for dictionary. Strings can be used, tuples can be used, and many other, but we're only focusing on iterables here. So you might say like, oh, I can use numbers as a key. Yes, you can, but the focus here is for iterables only. Alright, moving on to generators. So we have two types of generators. You have generator functions and generator expressions. So generator functions are functions that return with yield and not the keyword return. So they know exactly where they left off. Generator functions, I can write a couple of examples here, just running through the concept first and we get to the code. And then generator expressions, if you know list comprehension, that's kind of like an eco-friendly version of list comprehension there. So as I said earlier, generator functions or generators are iterables that create their element on the fly. So they are very much memory conscious. That means they don't store or consume a lot of memory. So when you're working with a lot of data, streaming, and anything that's memory intensive, generator iterables are much more preferred. So just an example, create a code here. So a generator function would look like this. Gen, take some iterable, and then let's say while true yield iter, or in fact we can do this. Let's create a counter. So yeah, so this generator, for example, repeats our iterator 5 times. Okay. Just go ahead and call my gem. It's a list 1, 2, 3. Right, let's see. We've got a generator function here, a generator object. I'm sorry. Now, if we convert this to list, here we go. We got this. Now we've created a generator function that returned the generator object, and then we converted it back to list, which is a container type of iterable. We can iterate over our generator, gem or mg. For I in mg, print I. We do this. We have to initialize. This is what I meant earlier. So once your generator is exhausted, you'll have to reinitialize it, or iterate it over, you'll have to reinitialize it, otherwise it won't work over and over again. So yeah, so this is a generator function. A generator expression, on the other hand, would look like, let's say we have a list that has 2, 4, 5, and now we want to square each number, but instead of, well, let's make something actually bigger. And now we want to square them, all of these numbers. So lig b. See, we got ourselves a generator object again, which is much more light on memory. We can iterate over it, or we can even convert it to list if we want. It's a lot of numbers, but as I said, if I square them, I can here. Yeah. And yeah, that's it. These are generator expression and generator function. The rest of them, I believe, are pretty much clear. And oh yeah, here we I talked about creating a custom iterable, like a custom list. If you want to create your custom list, you can do it. All you have to do is implement iter dunder iter method, just class my list. List def iter self. This returns self, and then let's add some list functionalities. Just the length. We return self data of the length, and then get item so that it can be indexed. Self, so data at all, we need to press index here. Okay, return. We can put like a control condition here if index is less than length of self.data, then we can return self.data square bracket index, right? And then some aesthetics with self return
Yeah.